Hi everyone. In this lesson we're going to learn the properties of parallelograms and then we're going to use those properties to solve problems. This is page number 1, and in this page I have a diagram with the entire family of parallelograms, and today we're just going to be covering the first one, the first parallelogram, which is like the parent of all the other parallelograms. So only we're concentrating on the parent figure of the parallelogram family. The two definitions that I have up here are very important, and they sort of apply to all the figures that we have over here. For example, number 1 says a quadrilateral is a figure with 4 sides, and that applies to all the figures on the parallelogram family because all the members of the parallelogram family are quadrilaterals. They are all figures with 4 sides. The other one says a parallelogram is a quadrilateral in which both pairs of opposite sides are parallel. And as you can see here in the diagram, the rhombus and the rectangle come from the parallelogram, which means that the rhombus and the rectangle are parallelograms, and the square comes from the rhombus and from the rectangle, which come from the parallelogram, which means the square is also a parallelogram. Therefore, the definition that I have here applies to all of them because all these figures are coming from the parallelogram. All of them are parallelograms, and therefore they have both pairs of opposite sides that are parallel. But today we're just going to concentrate on the first figure and its properties, and we're going to be using these properties to solve problems. We will cover the other figures in other lessons. So I'm going now to page number 2, where I have these properties and the exercises that I'm going to do for today. So page number 2 is this one, properties of parallelograms. So one more time, I start with the definition because it's a very important definition. A parallelogram is a quadrilateral in which both pairs of opposite sides are parallel. So by the definition, we know that this side is parallel to this side, and this side is parallel to this side, because that is what the definition says. And since we have parallel segments, then all the angles that exist when we have parallel lines exist here because that is what we have over here, parallel segments. So that's the first thing that we have to know, that we're dealing with two pairs of parallel segments. And so, for example, you could have same side interior angles. In this diagram, you do not have alternate interior angles, or you do not have corresponding angles, but you do have same side interior angles, such as this one here and the other one down here, or we could say this one here and the other one all the way up here. Those are same side interior angles, and we know that they are 280, so that would still apply here. So we look at the properties, the other properties that parallelograms have. The first one, opposite sides are congruent. So in addition to being parallel, they are also congruent. So I can actually mark them. This one is congruent to this one, and this one is congruent to this one. Opposite sides, the ones that are one in front of the other. So if you know the measurement for the top one, you know the measurement for the bottom one. If the side on the left measures 10 centimeters, then the right side also measures 10 centimeters. The next one says opposite angles are congruent. So we're talking about this angle here and the angle that is in front of it. I'm going to put names so that I can name them. So I'm going to say this is A, B, C, and D. So angle A and angle D are opposite angles, so they are congruent. Angle B and angle D are opposite, so they are congruent. So angle A is congruent to angle C, and angle B is congruent to angle D. So if you know the measurement for one, you know the measurement for the other, the angle in front of it. And if you know the measurement for B, you should also know the measurement for D. The next one says consecutive angles are supplementary. Consecutive means the two that are together, such as A and B. It says that they are supplementary. That means they are 280. And we know that that is true because that actually comes from the fact that we have two parallel lines being intersected by a transversal. So any two consecutive angles are supplementary, such as A and B, or such as B and C are supplementary, C and D are supplementary, A and D are supplementary. And the next one, diagonals bisect each other. A diagonal is a segment that goes from one vertex to the vertex that is opposite to that one. So for example, A and C, if we draw this segment that goes from A to C, that is called a diagonal. And then we also have another diagonal that comes from B to D. So parallelograms have two diagonals, and I'm going to draw them here. So like that, and the other one. Okay, so both of them are intersecting here at this point, which we can call, let's say, E. And the property says that the diagonals bisect each other. That means BD is cutting into two congruent parts the diagonal AC, so that segment AE should be congruent to segment CE. So I'm going to mark that here. AE congruent to EC. And the same thing happens for the other one. AC is cutting diagonal BD into two congruent parts so that BE is congruent to DE. So BE is congruent to DE. And those are all the properties of the parallelogram. And we also have the very important fact that is coming from the definition. So we have all those things here. So now we're going to be using these properties to solve problems, as I have here in 4 examples that I'm going to do. So the first thing that you have to do once you read the problem is look at what parts of the diagram is being involved in the problem. Are those sides, are those angles, are those diagonals, so that you can use the appropriate a property in order to solve the problem. So in number 1, it says quadrilateral ABCD is a parallelogram. It must be a parallelogram, so you can use the properties. Find the lengths of all the sides. So we are dealing here with sides, and we're supposed to be finding the lengths of all the sides. And I'm given the representation of 3 sides, but I need to use one of these properties, and it has to be the one that is dealing with the lengths of sides, which is number 1 that says here, opposite sides are congruent. That's the only thing that I know. I do not know anything about consecutive sides, but I do know that opposite sides are congruent. So I have here opposite sides, which are AD is opposite to BC. So I'm going to use the fact that these two are equal in order to solve the problem. So right now I'm not going to use DC because I do not know anything about this. The only thing that I know is that's equal to AB, but I don't have the representation for AB, so I cannot use it right now. So AD is congruent to BC. I know that because there's a property that says that opposite sides are congruent. And so I can write an equation using these two sides. And the equation would be BC is equal to AD. So that is 9x plus 3 is equal to 5x plus 11. So putting all the variables on one side, that would be 9x minus 5x, that's 4x. And 11 minus 3, that would be 8. And x would be equal to 2. So now I have the value of x, and finding the value of x, I can now find the lengths of all the sides. So AD would be 5 times 2 plus 11, and that will be 21. And so BC should also be 21. I don't need to do the computation because we know that opposite sides are congruent, but if you do, you should also get 21. 9 times 2 is 18, and 18 plus 3 is 21. And so now I can find DC. DC is 4 times 2 plus 20. And that will be equal to 28. And therefore, AV should also be 28 because DC is equal to AB. And that will be the end of problem number 1. Going to number 2. It says quadrilateral ABCD is a parallelogram. Find the measure of angle D. So again, we look at what parts of the diagram is involved in the problem, and we're now dealing with angles. We actually have the measurements of 3 angles, and we're finding the measure of angle D, which is this one here. And we actually don't have a representation for that angle, for the measure of that angle, but that is okay, that's not a problem. So what can we use over here? We have 2 properties about the angles of a parallelogram. One property says that opposite angles are congruent, and the other property says that consecutive angles are supplementary. So if we look at consecutive angles such as angle A and angle B, these two would be equal to 180. However, one has the variable y and the other one has the variable x. Therefore, we cannot set up one equation with two different variables. But I do have the other angle, which also uses a y, which is the opposite to angle A, angle C, and therefore I can write an equation with these two measurements. Because I know that opposite angles of a parallelogram are congruent, I can write this equation using one variable. So the equation would be measure of angle C equal to measure of angle A, because there is a property that says that opposite angles of a parallelogram are congruent. And now substituting, I have 2y minus 40, it's equal to y plus 10. So putting all the y's together on the left side, I will have 2y minus 1y, that's y. And then on the right side, 10 plus 40, which is coming from the other side, that is 50. So I know now that y is 50, which means that I can find the measurement of angle A and angle C. And after I do that, I can find the measurement of the other two remaining angles. So if y is 50, 50 plus 10, A would be 60 degrees. And so the other one should also be 60 degrees over here. If we do the computations, 2 times 50, that will be 100. 100 minus 40 is 60 as well. So we do get 60 on both because opposite angles are congruent. And now to find the measure of angle D, I actually don't even need to use this 4x, because I know that two consecutive angles such as C and D are supplementary. I know that these two together add to 180, so the measure of angle D should be 180 minus 60. So the measure of angle D is 120 degrees. And that is the end of problem number 2. The next one, number 3, says quadrilateral and OPQ is a parallelogram. Find NP. I need to find the measurement or the length of segment NP, which is one of the diagonals of this parallelogram. So we're dealing with the diagonals here. What do we know about the diagonals? There is a property that says that the diagonals bisect each other. So that means this piece is equal to this piece, and this one here is equal to this one here. So how do we write the equation? Well, we know that these two parts are equal, so the equation is going to be about these two parts. We're not going to use 5x plus 2 in the equation, but we will use later on to find the length of NP. So the equation should say right now 4x minus 2 is equal to x plus 10. So 4x minus 2 is equal to x plus 10. Putting all the variables on one side, I have 3x, and all the numbers on the other side, I have 12. 3x is equal to 12, and then solving for x, I have that x is equal to 4. So now I know what's the value of x, so I can know how much is this piece here, which is 5x plus 2. So that will be 5 times 4, 20 plus 2, 22. So this part is 22, which makes this part also 22. And therefore, NP would be equal to 44 because 22 plus 22 is 44. And the next one, it's another type of problem that you should be able to solve using the properties of the parallelogram. A classic example of a Regents question. And it says, in the diagram of parallelogram FRED below, ED is extended to A and AF is congruent to DF. If the measure of angle R is 124 degrees, what is the measure of angle AFD? So what do we have over here? We have that FRED, this one here, it's a parallelogram. So this is the parallelogram, the one that I'm highlighting in yellow. And then for that parallelogram, side DED is extended to A, and then AF, this part here, AF, is congruent to DF, this segment here. So we have these two segments equal, which is giving us that we have here an isosceles triangle. We have to be able to see all those things immediately as soon as we see this information. We know that this is an isosceles triangle. What else do we know? We know that the measure of angle R, which is this one here, that angle is 124 degrees, 124 degrees, that is for this angle here. And our job is to find the measure of angle AFD. AFD is this angle here. That is what we want to find. What's the measure of this angle? So these problems could be solved in different ways, but I would say one of the easiest ways to solve this one would be to use opposite angles of the parallelogram. This angle here at D will have to be congruent to the angle R. So this one here is congruent to angle R. So if this is 124, we can get this 124 as well. And now we can use the fact that we have here a linear pair to find the measure of this angle, which would give us also the measure of this angle. And then using the fact that we have a triangle and that the three interior angles of the triangle are 280, we could find this angle here. So using the linear pairs, this angle here is 56 degrees. Because 180 minus 124 is 56, so that's how we get this angle, because we have a linear pair. And so since this is an isosceles triangle, this angle here should be equal to the angle A. So I know that this angle is also 56 degrees. And so now I can find the measure of angle AFD, which would be 180 minus the measurements that we have over here, which is 56. So the measure of angle AFD should be equal to 180 minus 56 plus 56. So it's 180 minus 112. So 180 minus 112 is 68 degrees, and that will be the answer that we're looking for. The measure of angle AFD is 68 degrees. And that will be it for today on how to use the properties of a parallelogram to solve problems. Remember to always look at what parts of the diagram are we using or are being involved in the problem, and we look at the properties that are about those parts of the figure, and we try to use those properties to set up an equation in order to solve the problem. As always, check the class website to see what is the homework.